Hello everyone. In continuation to our previous videos, in this video let us discuss about electronegativity and also electron gain enthalpy or electron affinity. First let us discuss about electron affinity. Why? Because this is somewhat related to ionization energy which we have discussed just in our previous video. This is just exactly opposite to ionization energy. Ionization energy means what? It is removal of electron. Right? Here ionization means removal of electron, but here we are going to add an electron. Completely reverse. Here we are adding an electron. By adding an electron, due to the attraction between the nucleus and the outermost valence electron, that means the electron which we are adding to the outermost shell, due to that attraction, some amount of energy will be released. That energy which is liberated or released is known as electron gain enthalpy or electron affinity. By gaining the electron, it is going to liberate. Due to the attraction between the nucleus and the electron, some energy will be released. That energy we call it as electron gain enthalpy. So it is the energy released when an electron is added to a neutral. Here also the same. For the neutral, isolated gaseous atom only will be adding, just like the removal of electron in the case of ionization energy. The same manner we will be taking here. To a neutral gaseous isolated atom. Why we take an isolated atom is because when an atom is bonded to some other atom, it will have attractive interaction with that particular atom. So therefore, it may not attract the electron which is being added, or we may get the different values when we add an electron to already bonded atom. So therefore, we only consider the isolated neutral gaseous atom, and that we will be measuring the amount of energy liberated in kilojoule per mole. So here also the same factors affecting these electron gain enthalpies are very similar to that of the factors affecting ionization energy. Let us take an atom A. To this we are adding an electron, and this is a gaseous atom. Now by adding an electron, what happens? We have already discussed. So by adding an electron to a neutral atom, it is going to get converted into an anion. So here this is going to get converted into an anion. With the liberation of some energy, we call this energy as electron affinity, EA1, or simply we can write this as whole energy as EA1. See, the 1 is because here we are, this is the energy liberated when an electron is added to a neutral gaseous atom, same like ionization energy. And after adding an electron, it gets converted into anion. To this anion again, if we add an electron, we are going to get a negative. That means a ion with -2 charge, and that energy which is liberated we call it as EA2. Generally, most of the elements doesn't liberate much amount of energy by the addition of second electron. It doesn't prefer that it doesn't add an electron. It doesn't gain an electron. But here the amount of energy liberated will be less here. Why? Because by the addition of second electron, already an electron will be there. That means that species or that atom will be rich in electrons. So there will be a repulsion between the incoming electron and the already existing electron. So due to that repulsion, the addition of second electron will be somewhat difficult. So due to that difficulty, the liberation of energy will also be less, because there will be somewhat less affinity. Affinity means what? Somewhat attraction, affinity, affection. So that affinity will be decreasing. So for the first electron, the affinity will be somewhat higher. For the second electron, the affinity will be reduced or decreased because of the electron-electron repulsion for the previously added and the forthcoming electron. So due to that, the second electron enthalpies will be somewhat lower. That means they possess positive. Here actually, see here I need to tell one point. Here we will be showing them with a negative value, somewhat here that may be negative EA, means negatives here, the negative sign indicates liberation of energy, and here mostly positive EA. Positive refers or positive indicates that electron energy is required, added. So by using somewhat energy only we can add an electron in the case of second electron enthalpies. In the case of first one, energy will be liberated out. So when energy is liberated out, it is giving out energy, so we put minus, and in the second case it is requiring energy, so we put positive, right? So don't get confused with these signs. Negative means liberated, positive means it acquires or it gains energy to add an electron, right? So this is the case of electron affinity. Let us see its variation in the groups and periods, right? So in a group, if you take from top to bottom, you know that the size increases, therefore the nuclear attraction on the valence electrons will decrease. So what happens here, you can easily understand that when the electron is being added to the next element, what happens, the size increases, therefore the nuclear attraction on the added electron will be decreasing. So if the attraction or the affinity decreases, what happens, the liberated energy also decreases, right? So therefore we can expect that in a group from top to bottom, the amount of energy liberated will be decreased. That means the electron affinity decreases. Here in groups, EA values decreases from top to bottom. As we move from the top element to the bottommost element in a group, that EA value is going to decrease. So in a group from top to bottom, actually what should happen, as we move from top to bottom, the value should decrease. Electron affinity value should decrease. Here minus 328 to minus 349. So there is an increase. Instead of decreasing, there is an increase. And if we come to bromine, so the decrease is as usual. And if we go to iodine, also it is decreasing. But why in the case of these two, why there is an exception? Why there is an exception here? Why the chlorine is having greater affinity than the fluorine? This is because fluorine, due to its very small size, the addition of electron will liberate, or the addition of electron will not be affected, or the affinity will be less on the next coming electron. See, already it is very small, with a very small space, the electrons in it are completely packed. So the next coming electron will not be preferred by that particular element, because already there is a very small space, and the next electron will be very tight to enter into that particular shells. So therefore there will be somewhat repulsion. Due to that, the amount of energy is not usual, not as expected. There will be somewhat less amount of energy will be liberated. Whereas in the case of chlorine, it is as usual. Actually, this should have somewhat greater values than the chlorine. But in the case of fluorine, due to the size factor, the accommodation of the incoming electron will be difficult, and therefore it has liberated less amount of energy. Right? So this is a very frequently asked question. Why chlorine has a greater electron enthalpy than fluorine? So this is a reason. Next, coming to periods. You can easily assume what might be happening in the case of periods. In the case of periods, what happens? As we move from left to right, the atomic sizes will be decreasing. So due to the decrease in atomic sizes, what happens? The attraction on the valence electron should increase, and therefore the affinity also should increase per mole of energy. Why there is a positive value in the case of neon, nitrogen, and in the case of beryllium also there is a zero value. Why there is a difference is because in the case of beryllium it is zero. Why? Because the configuration is 1s2 2s2. It is having fulfilled configuration, so the addition of next electron will be losing or will be destabilizing the configuration, right? So yesterday while discussing about ionization energy, in the previous classes while discussing about ionization energy, we have discussed one point, stable configuration. Here also I have said that what are the factors that are affecting ionization energy will be the same factors that will be affecting the electron gain, enthalpy or electron affinity. So the same, beryllium is having stable fulfilled configuration. So by addition of next electron, the electron will be added to the p subshell. So by the addition of that electron, it is destabilizing its configuration. By the destabilization of configuration, it doesn't prefer. Already we have discussed, no element or nothing in the universe will prefer to destabilize. Everything in the universe will prefer to be stable. So by the addition of an electron, this stable configuration will be lost. So beryllium doesn't prefer to lose the gain the electron or lose the electron, right? So here that is the reason why beryllium has 0. And next coming to nitrogen. Why nitrogen is having 0? Why nitrogen is having 0? Because the same reason. Nitrogens, if you look at the configuration, its configuration is 1s2, 2s2, 2p3. Here it is with half filled configuration. It is with half filled configuration. That means the 3 orbitals of the p subshell are filled with 1 electron. It is half filled configuration. So therefore it doesn't prefer to lose that stable configuration. So by the addition of 1 electron, what happens? Here 1 electron will be added to the p subshell. So therefore its half filled configuration is lost. That means its stability is lost. So it doesn't prefer to lose the stability. That's the reason why it doesn't accept an electron. So therefore it also have positive or 0 around its electron affinity value will be 0. Right? It doesn't by the addition of electron, it doesn't give the energy. You see here, you should be very cautious. The positive values or the 0 kilojoules or the 0 value of electron affinity doesn't mean that they don't gain the electron at all. Definitely they will be gaining the electrons. They do get converted into negative ions, but their affinity, their ability to get converted into negative ions is very less. The amount of energy will be liberated by the addition of electron is very less. It's around 0. Here, next coming to neon. Again, the story is same. Here, neon is with configuration 1s2, 2s2, 2p6 with octet configuration, very stable configuration. So therefore, it doesn't prefer to lose the electron or gain the electron. The removal of an electron or the addition of electron will require more amount of energy. So here you will be asked why the that is alkaline earth metals and 0 group elements shows positive values. If you look at the other alkaline earth metals, beryllium, magnesium, calcium. Beryllium 0 kilojoules per mole, boron also 0 kilojoules per mole, and if you look at calcium, it is plus 2.4 kilojoules per mole, and if you look at beryllium, magnesium, calcium, strontium, it is plus 4.8 kilojoules per mole. So these alkaline earth metals and the 0 group elements, they show positive electron affinity values because they are with fulfilled configurations. They are with stable configurations. They don't prefer to gain an electron so that they will be destabilized. Right? So this is a reason for the different exceptions along the groups and along the periods for the case of electron affinity values. And this is how the electron affinity values will be varying in the groups and in the periods. Now let us discuss about electronegativity. Electronegativity is a property which is with respect to the atom which is bonded to other atom. In the previous two properties like ionization energy and electron enthalpy, these are the two properties which will be depending upon the isolated neutral gaseous atom. the electronegativity. Electronegativity is a tendency of an atom in the case of bonded. So let us assume that the two atoms A and B are bonded to each other. See, in these two atoms, this is a bond. That means a bond is formed by sharing of two electrons. Now these two electrons will be shared between the two atoms, and electronegativity of any atom in this molecule is defined as its tendency to attract these bonded electrons towards itself. Okay. See, in these bonded atoms, electronegativity, see, let us take the example of B, atom B. The electronegativity of an atom B is the tendency of B, of that atom B, to attract these bonded electrons towards itself. To attract these bonded electrons towards itself is known as electronegativity. Coming to the values, Mulliken has given a scale. He has stated that electronegativity is the average of ionization energy and electron affinity. So he has given the formula like this: electronegativity is equal to the average of ionization energies and electron affinity values. But this is not much accepted. Later, Pauling has given a scale. He has given the electronegativity value of hydrogen as 2.2. He has fixed the value of hydrogen as 2.2, and he has calculated the remaining elements with respect to the hydrogen. Based on hydrogen, he has calculated the remaining elements electronegativity, and that is more successful, and that is being followed now. As the electronegativity values are relative with respect to hydrogen, we don't have any units for electronegativity. Now, variation. Before going to variation in groups and periods, let us also discuss about the factors affecting electronegativity. See, what are the factors that affect ionization energy and electron affinity? The same factors will be affecting the electronegativity. Remember those factors, and you apply those factors here in the case of groups and the periods. Definitely you can understand the variation. Simply, you imagine the nuclear charge. What happens in the case of groups? From top to bottom, the nuclear charge is going to decrease due to the increased atomic radius. And here in the case of periods also, the nuclear charge is going to increase. Why? Because the electron is being added to the same shell, so therefore the nuclear charge will be increased. Right? That is a major factor which will be varying the electronegativity in the case of groups and periods. See here, in the case of groups, if you move from top to bottom, you can see the narrowness. See here, from broadness to the narrowness. This means that the electronegativity values are higher at the top and they are lower at the bottom. That means as we move from top to bottom in a group, the electronegativity values are going to decrease. And in the case of periods, the electronegativity values are going to increase. This increase is due to the increase in nuclear charge. So narrowness towards from at the left hand side and broadness at the right hand side. This means that this will be low at the left hand side, and as we move to the right side, the values will be increasing. So these are the values. Fluorine is the most electronegative element in the whole periodic table with electronegativity value 4. Fluorine with 3, bromine 2.8, iodine 2.5. See, as you move from top to bottom in this group, that is a halogen. This is a halogen family. In the halogens, there is a decrease in the electronegativity. And this is a second period elements. In these second period elements, you can see there is a gradual increase starting from 1 to neon. So that's up to fluorine, the values are keeping on increasing. So this increase is due to the increased nuclear charge. This is a very important concept: electronegativity, ionization energy, and electron affinity. So with based on these factors only, these properties only, you will be understanding how the chemical reactions will be taking place. In your higher classes, you will be studying about chemical reactions. There you will be understanding those chemical reactions only based on these properties. So be thorough with these properties and try to get clarified whatever the doubts you have in these concepts.